Well, good morning. It is Tuesday, April the 6th. We are just cruising rapidly to May 7th, our deadline. We are going to be finishing up this chapter today, really. Okay? We have the quiz on the lab tomorrow, and then tomorrow and Thursday are just practice. Thursday is probably going to be Princeton Review Day. Okay? Test is going to be on Friday. So we all need to just be ready for that. That's going to be our last main big test. Then we start the review process, and when I was looking, and we actually going to have almost 4 full weeks of review, which is going to be awesome. And so we're going to kind of use that to kind of go through. We're going to use old AP tests to kind of review back certain concepts and make sure that we remember the little nuances and little things for each test. I will also give you back every single test that you've taken all year long with all of your corrections in a folder, and you will be able to then use those also as practice, problems and multiple choice questions and things, just to kind of go back and refresh yourself on those. All right, so today we're going to do the last thing. So far we've been talking all about voltaic cells. We've been talking about E red minus E ox, and in order for the reaction to be spontaneous, for the reaction to occur, what has to be the sign of E cell? Positive. But we can make reactions that have a negative E cell happen, but it requires energy, it requires work. So we put energy in, and when you put energy into a system to cause a reaction, it's called electrolysis. Okay? Now there's just going to be several terms that we're just going to have to learn, or just know. That current, it's measured in amperes, which is abbreviated amps, which is coulombs per second. A coulomb is a measure of electrical charge. And then when we talk about voltage, that's my cell potential, my EMF. Okay, it seems like there's one more that I'm forgetting, but when we get to it, I'll remember it. What we're going to be doing though is we're going to be putting electricity into a solution and causing a reaction to occur. So So this is really what we're going to do. Okay? What does it mean, molten NaCl? Melted. Molten and melted are pretty much the same thing. Okay? It's just usually when you see her molten, you think gooey, thick, very viscous, just kind of. So we're putting electricity in, and the sodium, again, notice what's happening here. Sodium is going to sodium liquid. So what process is occurring right here? Reduction. So it's the cathode. Here, the Cl minus is being oxidized to Cl2, so this is going to be your anode. Okay, electrons are going to flow from the anode to the cathode. Now, if I looked at the E cell for this, it's going to be a negative value. It's not going to really want to happen, but we're going to put energy in, we're going to do work, we're going to supply this energy and make it happen. Okay? Now, these problems are going to be much more analytical, and really the common things you do this is electroplating. Again, you can put chrome onto steel, or you can electroplate one metal onto a more expensive metal onto a cheaper metal and just have a very thin coating of it. So it looks like the whole thing is the expensive metal, but it's really just a thin coating on it. And so that's the most common use. But the problems that we're going to do are going to look very much like this one right here. I can do this. I don't want you to see the answer. Okay, it says calculate the number of grams of aluminum produced in 1 hour by the electrolysis of molten aluminum chloride if the electrical current is 10 amps. Oh, that's the one I wanted to do. We have a Faraday. We know that a Faraday is equal to 96,485 coulombs per mole of electrons. Okay, that's a constant that we need to know. Now, in these problems, we're going to go mass to moles of electrons, to charge to time. We're just going to kind of go back and forth one way or the other. It's just kind of going to be how it's all going to work. But this is all going to be units. We have coulombs per second, coulombs per mole of electrons. We're going to use the molar mass, which is grams per mole. And we're going to use N. N is equal to moles of electrons transferred per mole of substance. So those are all just going to be our units. So when I'm looking at this one, I'm going to start, the question's asking for grams, so I'm going to start over here with time, okay? And the current is always going to be given. So this A stands for amps, which means it's coulombs per second is the actual unit on it. So I'm going to start with my time, 1 hour. But what's my charge? What's my current measured in?
Seconds.
Seconds. So I got to take hours to seconds. So how many seconds are in an hour? 3,600. Don't confuse. A lot of people have common mistake. They put 60 seconds in an hour. And I know that that's how this class seems like. You know, just the hour just goes by just like that. You know, but it's 3,600 seconds in an hour. You're agreeing with me. I appreciate that, Amar, shaking your head. Okay? So 3,600 seconds in 1 hour. Okay? So now I have seconds. So now I need to go to charge. And what I have, the conversion factor that I have with seconds in it is amps. So where do seconds need to go? On the bottom. So I'm going to say my current is 10 coulombs per second. Seconds need to go on the bottom, so I'm going to say 10 coulombs per second. Seconds cancel. So that's going to leave me with, well, how much charge? What's the total charge that's going through my wire at this point? Okay? So it's going to be 36,000. So I got 36,000 coulombs going through. Well, how many moles of electrons is that? Well, I have coulombs here, so the only other thing with coulombs in it is the Faraday. So I'm going to say 1 mole of electrons is equal to 96,485 coulombs. That tells me how many moles of electrons I have going through my wire. Now, here's where we go to the substance, N. how many moles in this, if I'm going from AlCl3 and I want to go to pure aluminum from this, what's N going to equal? 3, because it's going from +3 to 0. I know that it's +3 here, and pure aluminum is going to be 0. So I can say then that there's 1 mole of aluminum for every 3 moles of electrons. Moles of electrons cancel. So that tells me how many moles of electrons, there's enough electrons to electrolyze this many moles of aluminum. Okay? But I want grams, so how do I go to grams? Molar mass, which is 26.98 grams over 1 mole. So it's all just conversion factors. So then you're going to go, you don't need to do the 1. We already have 36,000 divided by 96,485 divided by 3 times 26.98. This all equals
3.36.
3.06?
36.
3.36. So you have a metal electrode in here, okay? And you're putting electricity in and you're wanting to get pure aluminum. Well, if you run 10 amps of current for 1 hour, you're going to be able to get 3.36 grams of aluminum plated out. Now, if you're doing just a thin coating on a piece of metal, 3.36 grams will go a long way, because you're only doing a couple atoms thick across the top. Okay? So, it's just conversions. So if we go, I'm getting all this out of the textbook, okay? We look at this sample problem right here. This one now says how much time. So in this one, how much time, I'm going to start here, and I'm going to need to go to time. I'm going to go the opposite direction. Everything's just going to be in reverse. So how much time is needed to deposit 1 gram of chromium from an aqueous solution of chromium chloride using a current of 1.5 amps? Well, what do I start with? 1 gram. What do I need to do with that 1 gram of chromium? Convert it to moles. Okay, I'm going to go do this time. Okay, so we go to chromium, it's 52, I believe, 52.0, 51.996, so I say 52.00. Okay, so that gives me grams. So now I have moles of chromium. What conversion factor is going to have moles of chromium in it? N right here, right? It's going to have moles of electrons per mole of substance. Okay, so what's N going to equal in this one? Again, we're going here, so it's +3, and the metal is always 0. For 1 mole of chromium. Moles of chromium is on the top, so I put 3 moles of electrons for every 1 mole of chromium. So now moles of chromium cancel, so I'm left with moles of electrons. So what has moles of electrons in it? A Faraday. Moles of electrons, these go on the bottom, so it's 96,500, 485, sorry. For 1 mole of electrons. So what has coulombs in it? The amps, right? And that's given here as 1.5 amps. So that's 1 second, 1.5 coulombs. So now all of this is in minutes. So we have to convert it to minutes. Okay, so 1 minute, 60 seconds. All right, it's just units.
It's C.
Okay, it comes out to 62.
Yeah, 61.85 down.
61.85 minutes, which we can go to 62 minutes. Now the sig fig, yeah, why 2 sig figs?
The
1.0 is 2 and the 1.5 amps is just 2. Okay? So go ahead and just do the practice exercise 2 right there. Just do A and B just for practice. That is on page 895. That's as big as I can make it. I don't know, does that make it any better? that will be sections 20.7 and 20.8. Read it for comprehension. That's kind of a guide of what you need to know. Okay, but there will be questions on the test out of those two sections. All right, did we get these right? Okay, so let's look at these. The half reaction for the formation of magnesium metal upon electrolysis of molten MgCl2 is given. Calculate the mass of magnesium when you pass current of 60 amps for a period of 4,000 seconds. Okay, so again, we're starting with time this time, we're going to mass. So, it's right at 4,000, yeah, 4,000 seconds. So what conversion factor do I want to use with seconds in it? Amps, right? Okay, so I'm going to use, it's given as 60 amps. So that's going to be 60.0 coulombs for every 1 second. Okay, so now I have a charge. What has coulombs in it? The Faraday. So I say 1 mole of electrons for 96,485 coulombs. And that, again, this number is given in your equation sheet, so you don't have to memorize that number. Now coulombs cancel, so I have moles of electrons, so now what do I use? N, which is going to be, for this one, it's going to be what? 2. And it kind of even tells you right there with that 2. Okay? So it's going to be 1 mole of magnesium for every 2 moles of electrons, and then to go to grams, 24.3 grams over 1 mole. And that all turns out to equal? Anyone? 30.23? So let's say 30.2 for 3 sig figs. That's grams of magnesium. So that's how much magnesium could be plated out if you, for 4,000 seconds, ran a current of 60 amps through that. Now, just so you know, most of your electrical plugs are going to be a 15 to 20 amp on a 15 to 20 amp circuit. Okay, just to kind of give you an idea of how much each thing is. It's 110 volts, but it's about, again, it depends upon whether it's a plug or a switch. It's going to be 15 to 20 amps. Now your oven is going to be on a 50 amp. If it's an electric oven, it's going to be a 50 amp circuit. Dishwashers on a 30 amp because they require more heat because they have those heating elements. Okay? So B, how many seconds? So now we're going to go the opposite directions. 50 grams of magnesium if the current is 100. So we go 50 grams magnesium, 1 mole, 24.30 grams, times what? 2 moles of electrons over 1 mole magnesium, that's my N, times, okay, 96,485 coulombs over 1 mole of electrons, times your amps, which is 100, so 1 second over 100 coulombs, and that's actually what we're looking for. And it turns out to equal how many seconds? 3,000, so let's give me 3 sig figs, 3,900. And we could convert that to minutes or hours, right? We would know how to do that, dividing by 60 or through 3600, depending upon what the time function is. Okay, so electrolysis problems are really dimensional analysis problems. Is just start with the given, whichever one is just one unit, grams or seconds or whatever. And then you just kind of go to what you need. Yes, sir.
We're gonna have to calculate wattage.
No. Okay? So, looking at the sheet that I just gave to you, look at 1992. It says a solution, an unknown metal M forms a soluble compound MnO3 2. So what do I know the charge is on M? Plus 2, right? Because we memorized that NO3 is -1. Okay? So I know M is plus 2. So that gives me my N. If I need anything on that, I know N. A solution of MnO2 to MnO3 2 is electrolyzed when a constant current 2.5 amps is applied for 35 minutes. 3.06 grams of metal M is deposited. Calculate the molar mass of M. That's something different. What's molar mass? Grams per mole, right? So when you're doing these problems and you get, there's tons of numbers and words and all kinds of stuff and it's overwhelming, start with the question. What's the question ask? What's the molar mass? And we know that that's going to be grams of M divided by moles of M. Right? Do we know either one of those from the problem? We know grams, right? We have 3.06 grams were deposited. We just need to know, well, how many moles of M were there? So see if you can figure out, how do I figure out how many moles of M from all that given information in that problem? an answer? Not quite. Okay, so just before the bell rings here, let's go through this. So what do I start with here? 35 minutes, right? So I have 35 minutes. I have to convert that to seconds because amps is always in seconds. So we have 60 seconds for 1 minute. Now again, we don't count this in sig figs, the 60, because by definition it's exact. Okay, so just a reminder on that. Okay, so now what? Amps, which is 2.50 coulombs for 1 second. Then what? 1 mole of electrons, 96,485 coulombs. Then what? N, which is 2. 1 mole of M for every 2 moles of electron. Does everybody know where we got that 2 from? That's the importance of this right here. Okay? And then what?
That's it.
That's it, because we're looking for moles. We don't have to go to grams. So we can't go to grams because we don't know what the molar mass of M is. That's the whole thing what we're trying to find. Okay, but again, if you don't know what you're looking for, you're probably never going to find it. That's why we start with the question. Molar mass is grams per mole. Well, I know grams, I need to know moles. So when you know where to stop, it's here. So what do we get? How many moles?
0.037.
Is that what you guys, do I agree with that? Moles of M, so I put that up here, 0.027 moles. And what's the molar mass turn out to be? Here was a mumble. 112?
112.5.
And so then you just go to the periodic table and you find a molar mass of 112, and it's cadmium. Okay, so we can use this again. The question, you're not necessarily always going to go mass to time or time to mass. You could have to ask you to stop in between. We're going to do another one when we come back that's going to ask us to find N. Okay, well, what's the charge? How many electrons got transferred to know the formula of the compound? Okay, so we may have to find different things in here, but we can always, it's always just starting with the given and then just stopping with whatever we're looking for. But it's always going to be this type of thing. Yes, ma'am.
Is the variable number an exact number?
No, that would be 5 sig figs though. A lot of, when they put constant tables or whatever, they just do 96,500 even for that. All right, so let's look at B. The metal identified in A is used with zinc to construct a galvanic cell as shown below. Write the net ionic equation for the cell reaction and calculate the cell potential. Okay, so now we know it's cadmium. Now, on this year, you would have had a list of reduction potentials like page 1105 in your book. Okay, so you do have access to that to determine which one's being oxidized, which one's being reduced. So you would have the cell potentials. Nowadays, they would just include it within the problem. Okay, so let's go ahead and do that. Zinc's 0.34. Anyone looking it up yet? One sec. Yeah, go with the other one. Copper's the 0.34. And what's cadmium's?
Negative 0.403.
0.403. Okay, so those are the values that will be given.